Hi, this is Kelsey here from Math Sisters. Today I'm going to be talking about simplifying radicals and perfect squares. So first I want to break down what a radical is. This is our radical sign right here. Sitting outside our radical is always our index, kind of looks like it's raised up kind of like an exponent. Now if there is no index, if we just have this right here, think about there being an imaginary 2. So on all other ones, it would have a number there, but if there is no number, you would say the index is 2, so it's a square root. That is the only one that is special. Besides that, you could have a 3 there, that would be a cube root. You could have 4 there, that would be a 4th root, 5th root, and so on. We usually mostly work on in Algebra 2 and sometimes in Algebra 1, but mainly just square roots in Algebra 1. Inside our radical is our radicate, so we'll have perfect squares there or non-perfect squares. First, I'm going to list out what perfect squares are. So a perfect square is a square root of 1 is 1 because 1 times 1 is 1. So we have 1. Another perfect square is 4 because square root of 4 is 2. 2 times 2 is 4. And then from there we would say 9 because 3 times 3, 16, 25, 36, 49, 64, 81, 100, and so on from there. Okay. Now, if I was just to work out a perfect square, if it's a basic radical, it would just look like this, square root of 16. What is the square root? Well, we just talked about what the square root of 16 is. It is 4 because 4 times 4 is 16. So we have a pair of 4s. Anytime you have a pair, that pops out. So our answer is just 4. Now going into breaking down square roots, we're going to first start with square root of 32. So we're going to simplify this radical of 32. And how I think it's the easiest way is to do your factor tree. What multiplies to give you 32? And there's multiple answers here. We could do 8 and 4, 16 and 2. Any of those work as long as you go to a prime. Just remember what a prime is only 1 in itself can multiply. So example of prime would be 2. Only 1 and 2 multiply to give you 2. 3, 5. Only 5 times 1 is 5. That's it. 7, 11. And it just keeps going up from there. So let's go down to our primes. I'm going to do 8 and 4. And then I'll go 4 and 2. Now I could stop right here and say I have a pair of 4s. So what is going to pop out? Just a 4. Because 4 times 4 is 16 and square root of 16 is 4. So think of this being 16 right now. They're always multiplying on the inside. And whatever is left, this 2 is left, you already used the 8, you broke it down, goes inside. It is now our radicate. And we are done there. Now some people might actually have kept breaking that down right here, the 4s, and you would get the same answer. It's just you would have 2 pairs of 2. When in doubt with radicals, you always multiply. So 2 times 2 is 4, and 2 times 2 is 4, so we are going to have 4 on the outside and a leftover 2 on the inside. Same answer. Now moving into other examples, let's try square root of 180. What breaks down to 180? And there are multiple things. I'm going to just start with something easy, 90 and 2. If you can't think of anything, a lot of times try 2 or 3. And then 90, you could do 45 and 2. 45, you could do 9 and 5. 9, you could do 3 and 3. So we have a pair of 3s and a pair of 2s. When in doubt with radicals, you always multiply. 3 times 2 is 6. And we have a leftover of 5. We already used 45, we used 90, we used 180. So 5 is our leftover, and your leftovers go inside and become our radicate. Just remember our index right now, we're doing square roots, so there's just imaginary 2 sitting out there. Okay. Now let's do one that there'd be a number sitting outside our radical. So here, for example, would be 2 square roots of 54. What breaks down to give us 54? That could be 9 and 6, 3 and 3, 2 and 3. We have a pair of 3s. Now when I bring that out, this time it's affecting that 2. When in doubt, multiply. So 3 times 2 is 6. And we have what left over? Now there's a 2 and a 3 left over. So again, when in doubt, multiply. 2 times 3 is 6. So our answer is 6 square roots of 6. And our last example for today is, what if a negative is sitting outside? Does it change it at all? We have negative 3 square root of 28. What multiplies to give us 28? We could do 14 and 2, and that would give us 7 and 2. We have a pair of 2's. Now again, this 2 is being affected by that negative 3, so I multiply. 2 times negative 3 is negative 6, with a leftover 7 as my radicate. So that is the end for today. Again, this is Kelsey from Math Sisters. Thanks for joining.